My dear students, welcome back to the lectures of formal languages and automata theory. In this video lecture, we are going to discuss about push-down automata to context-free grammar, conversion of PDA to CFG. See, in the previous lecture, we have converted from CFG to PDA. Now here we are going to convert from push-down automata to context-free grammar. So, see, here we are going to follow some rules. Generally, we have three rules here. Please observe the three rules which we are going to use in the problem. So, based on these three rules only, we are going to convert given PDA into CFG. And see here, our first rule is S productions are given by S implies or S derives Q naught, Z naught, Q for every Q belongs to capital Q. Now we will understand that suppose if the states are in the given PDA, we will observe totally how many states are there. If suppose only two states are there, like Q0 and Q1, consider there are two states in the given PDA, Q0 and Q1. So for every state, we have to write this production form. I mean, first we will substitute Q0 in the place of Q here. After that, we will substitute Q1 in the place of Q. So what productions we will get if both Q0 and Q1 are the states? If both Q0 and Q1 are the states, we will get the productions like S derives Q0, Z naught, Q0, Z naught, Q0. Again, one more production. Now we have substituted Q0, still we have to substitute Q1. S derives Q0, Z naught, Q1. This is how we are going to write the productions for the given, with the start symbol. So our first step is we need to identify what are all the states, number of states given in the PDA. So for all the states, we will write this PDA equation, this context-free grammar production form. So we have to write this production. For all these states. Just we will substitute the states here. If Q0, but the states are Q0, Q1, and Q2. We will write the three equations. S derives Q0, Z naught, Q0. Again, second production. S derives Q0, Z naught, Q1. Third production. S derives Q0, Z naught, Q2. So this is how we will write productions for the given PDA, for the given number of states. So our second one is, see here, in the given PDA, we need to observe whether push operation is taking place or a pop operation is taking place. Suppose if push operation is taking place, then we need to identify and we need to consider the production into the form of this one. Delta of Q, A, Z equal to Q1, Z1, Z2 and so on, Zm. And it gives many productions of this form. Suppose if the production is of the form like this, any production of the form like this, so any production which is taking where push operation is taking place. So identify all the PDA equations where the push operation is taking place. Consider the production is in the form of like this. And when the production is in the form of like this, you please apply or implement that production, convert this production into this form. Q, Z, Q dash implies A, Q1, Z1, Q2 followed by Q2, Z2, Q3 and so on, Qm, Zm, Q dash. So this is for each non-arranging move, that is push operation. For push operation, we will take this. And suppose if any pop operations are there in the given PDA, we will go for the move of each erasing move. We will go for erasing move. What is this? For pop operation, we will implement this rule. Delta of Q, A, Z equal to Q dash, epsilon. Suppose if the production is of the form like this, We will assume the given production in the form of like this, and after that we will convert the production like this. Q Z Q dash implies A. This is how we will convert each and every production. So that we will write all the converted productions finally. That doesn't mean the context-free grammar. That doesn't mean that we have converted PDA to context-free grammar. So these are the three rules we need to remember. See, this is the procedure for converting PDA to CFG. Once again, I am repeating. First one is, for all the given states, suppose in the PDA, please observe what are the how many number of states are given. If two states are given, like Q0 and Q1, we have to substitute Q0, Q1 in the place of this equation individually, only in the place of last Q. Okay. So what I told you, if the given states are Q0 and Q1, what I told you, first we will substitute Q0 in the place of Q. We will get one production. After that, again we will substitute Q1 in the place of Q. Again we will get one more production. We will write both the productions, and that is how we will form the productions by using the given states, by using this production. And now second one is what? Second thing. What I told you, two things you need to identify. Whether the given PDA equation is of the form of whether the given PDA equation is in push operation or pop operation. Please observe that pop operation means epsilon. It will be in the form of like this, Q comma epsilon, like this production. Pop operation will be like this. So if any production of the form like this, delta of Q comma A comma Z, then please convert that production into the form of this one, Q Z Q dash implies A. So that is pop operation, when pop operation is taking place. When push operation takes place, consider the equation is in the form of like this, and please convert the productions into the given PDA, the given context-free grammar equation. This is how we are going to convert. See, we will analyze this. We will analyze these rules with an example problem so that we will understand very clearly.